There's more than one way to display a line of text. You can display it directly, or you can store a line of text in a special object before you display it. The reason for this is that you may want to do something to it before you display it. This example program shows you some different ways of displaying text. I don't think I have all of them, but this program includes enough of them that you should be able to solve just about any text display problem you may have. As you can see from the list of import statements, you're going to be introduced to a few new classes. The constructor of this class creates a new font object containing the font that will be used throughout the program. It's a standard Times Roman font set to bold and 32 points. The only other thing that happens in the constructor is that the size of the window is set. The paint method sets the font in the graphics object and then consists of a list of method calls. Each of these methods displays the line of text in its own way. Notice that the X and Y positions of the text is passed to each of the methods. In the simple string method, a line of text is displayed in the standard way. A call is made to the drawString method with the text of the string and its X and Y positions. The method SimpleCharArray displays an array of text. Using some of the methods of the string object, it's possible to convert a string of characters to and from a string object. But it's sometimes more convenient to work with a simple array of characters. This can be particularly useful when you are working with dynamic text. There are 5 arguments to the method drawChars. The first one is the array itself. We haven't done much with arrays in this course, but I'm sure you know that an array is an object, and that when you pass it like this, you pass its address. Anyway, the next 2 arguments are the start and ending indexes of the characters in the array. You can use these values to select just the portions of the array you wish to display. The final 2 arguments specify the location of the beginning of the string on the display. The simple text layout method starts off with the creation of a font render context object. The font render context object contains the stuff needed to do some measuring and whatnot on the text itself. In this method, we don't do any of that. We just sort of use it as a text storage place. The font render context constructor takes 3 arguments. The first one, which is null in this example, can be an affine transform that can be used to change the position and whatnot of the text as it is drawn into this object. The second argument, being true, would indicate that the text is to be anti-aliased. The third parameter, being true, would indicate that fractional metrics are to be performed on the text itself. These last 2 parameters have to do with the appearance of the font when it's scaled and sized. The results you get from these depend a lot on the screen you're using for display. If you're interested, you can experiment with this stuff to see what happens. The outline text layout method displays the outline of the text instead of filling the body of each character the way it's usually done. It starts off by creating a font render context object just like the one in the previous method. This object is combined with a font object and a string of text to construct a text layout object. And the text layout object has a method named getOutline that returns the shape object that contains the outline of the text. The argument used in this example is null, but you can pass it an affine transform that will be applied to the outline text in the shape object. Now the shape object is drawn to the screen with the draw command. We want the text to appear at a specific spot in the window, and there's no way to pass X and Y values to the draw method. So there are several ways to solve this problem. For one, the affine transform could have been passed to getOutline, and it would have moved the shape itself. I chose to do this one in a different way. Calling the translate method of the graphics 2D object, I was able to modify the internal affine transform so the shape was moved to another location. But notice what happens after the draw command. Another call to translate is made to put things back the way they were to begin with. This is necessary because the same Graphics 2D object is going to be used to draw some more text, and the transform would throw things off in the future. The simple attributed string method creates an attributed string object containing the text of the string itself. The getIterator method is called, and an iterator object of the attributed character iterator class is returned. This class can be used just like a string class for drawing. The Graphics 2D class has a drawString method that accepts an attributed character iterator object.